Hello, this is Philip. I've never done this before, but I've been working on a compiler called GCC Rust, so it's all about adding Rust as a language to the GCC toolchain. Something that I've always really enjoyed on the internet has always been things where people are sharing their own creative endeavours, be it in any field, but most interestingly would be in software engineering. So I really like the work that Andreas Kling's doing on Serenity OS, and I really like other projects like that, you know. So I kind of thought it might be interesting if to share what it's like to work on GCC Rust. See some of the pitfalls, maybe you might find something interesting, might encourage you to maybe want to contribute. It's written in C++, we're using C++ 11, and it's pretty interesting. We've made a lot of progress in about a year, and one of the things I'm working on right now, which I'm going to maybe try and fix, is for instance this piece of code here. So you can see here there's trait foo, which defines two trait items, static function default and a method get. And so whenever you have generic functions like this, so you can say t must implement foo, but really what we would call that is a type bound. So you're saying that this type is completely bound with these attributes. You know, it's able to do what foo can do, you know, and so whenever this function is actually called, we're asserting that whenever this type is substituted, that it must conform to that, and whenever we actually call the function, whenever we actually check, we do the type checking, not only just checking that t is the same t here, we're also going to check that the argument passed in also conforms to those types. So one of the things that's missing here is actually enforcing this. So for instance, if I go to the command line, let's see if we can make this viewable. Yes, so we can see here in this example we've got that trait foo, resizing it, struct bar, we've got that same type, same function, but actually whenever we're calling that function, we're calling it with bar, but actually bar does not actually implement trait foo. So this should error. So you can see here from my previous testing, you know, Rust C will say the trait bound bar foo is not satisfied, you know, so foo is not implemented for bar. And at the minute, I've got a bit of code in here. Let me remove it to show you what will happen. So actually, where did I put that in? I've basically thrown in a GCC unreachable to get to a point where I know I should be doing something here and just crashing to get the stack trace. So that's why that's there. But let's see. This is some debug. We don't have like a logger or anything like that yet. There is a patch to add that, but it's not merged yet. So whenever I'm doing a lot of development, I'll tend to do a lot of like Rust debug lines like this. We have, whenever we actually turn things into types, we do have like, you know, dash debug, which will do the printf part of it for you, but which is it's really useful for GDB, but I still love using printf debug. GDB is fantastic. I mean, at the same time, every time I am working with this compiler, I mean, I'm running it in GDB every time. So yeah, every time we just run make, and that's actually, it's quite nice that GDB will pass that on through for me. So let's see what happens. It's interesting though, because resolving this stuff it's pretty tricky. So if you look back at the example, say for instance the working case where bar does implement foo. The thing is, when we're inside a generic function, Rust is very well designed. One of the coolest things about generics is that in some ways it's actually quite simple. So in C++ language, when you have a template function, what you really care about in terms of type checking is whenever it's substituted throughout and doing the type checking there. So there's actually a lot of useful functions in GCC for doing that type of thing, but we don't actually have to do that for us. So whenever you get a generic function here, we're saying the bounds of the type parameter. So that means you actually can do your type checking on the generic function. But what that allows you to do is the only real then checking, whenever you only have to check how you're invoking it so that you are matching those trait bounds. So yeah. So because this thing should error, this will probably crash. Yeah, we get a crash. There's some debug there. That's just debug for me starting to look into this issue. So you can kind of see here that actually there's some substitutions going on here, but then this is the interesting one here, that the type parameter t is substituted with an inference variable, and the required bounds of this type parameter is this trait foo. So what does that mean? Whenever we're actually calling this function, what is actually happening here, the type bound test is referring to here, but type bound test needs to be substituted. But because there's no turbofish here to say, like, you know, type bound test going on I32 for example, the compiler has to try and infer what the type parameter is, and that will happen based on what the argument is being passed in as. It's just so that that we still conform to the type inferencing here. So there's a few changes that need to go on here to be able to actually support all of this stuff. So the bit of code that already works is, alright, we'll do the good case. The good case, just to show you that working. So we just want to start implementing it. What happens then? Probably get, yeah, we're missing default and get from this, so right, we need to implement. Let's just copy these. Just say returns 1, 2, 3. We'll say self.0. So we can say that, just to give some context to these blocks. These test cases look like toys, but when you're writing in Compiler, you kind of need to start out from the most basic form. So whenever I actually come to handling this, there's actually a few things going on here. So we're calling t the path t default. So what's actually happening here is the compiler has to look at t. Or what is t? It has type bound foo. Look in here. Oh, there is a trait item called default specified. There's also then the other case where we're saying a method call expression. So that's a call expression, and the bit in here is actually a path expression. There's a couple of bits is similar-ish here, where you have a actually, I'm not sure what the left-hand side of that is off the top of my head right now. It's probably like identifier or something like that. But then this is another type of path. So we're saying A is the receiver is of type parameter. So similarly, it has the trait bounds foo. So we can then resolve it to that. But the difficult part here is that I think Rust refers to this as monomorphization or something like that. So whenever you actually go to substitute in the actual correct type of bar, when we call it, what's actually happening is here the type resolver can only resolve this to one of the trait items. It doesn't know anything about the other implementation here. And so it's actually at the moment in the compiler, what happens in the back end is it says, oh right, we've resolved it to a trait item, but we need to be sure that that it may actually be more correct to resolve it to one of these implementations here. So we actually then have to check for that as well. So that's why there's a lot of these test cases look a bit weird, but it's just that we're trying to test these awkward cases as best we can. There's also the case that a trade item might actually give a default implementation, but that's actually not supported yet. I will do that in another video, which actually I put in a GCC unreachable there to say that right, that crashes, we know it's not supported and we need to do something there to actually implement this. It's pretty interesting for my first video to actually jump in to do something as complicated as this. The whole trait system in Rust is what I think is most powerful. I think sometimes the whole memory safety things of Rust are maybe they're really important, they're really cool, but for me what I think is really cool about Rust is more so that the core language is so well defined and that it actually forces you to start thinking about design patterns and clean code from the get-go, because you have things like it's immutable by default. In C++, for instance, that's not the case, so you end up being like, oh well, everything's mutable. That's pretty useful right now. I'm not sure what the design pattern should be, which is really useful for prototyping or when you're not sure what you want to happen or what sort of system you're building, or you have a lot of freedom that way, but there you build up technical debt at a rapid pace that you have to address down the line, which can be more and more difficult. Rust kind of forces you to start thinking about that from the start, which in some ways you could argue that it makes it less attractive for prototyping, but much more attractive for creating long-standing, stable solutions that you can trust. I think what's one of the successes of Go actually is just something as simple as that. Actually, Go test is built in to the language by default, and Rust is similar. Whereas doing unit testing in C++, you're spending an afternoon figuring out what library you want to use, and they all have downsides and pros and everything. And then you realize Google Test is fine. Let's just use Google Test. It's grand. Anyway, let's get back to this. Okay, right. I just want to show you that the actual case works. So now that we've given an implementation for this stuff, compiles without error. But the main bit I'm always interested in is there's a few debug outputs. There's all these dumps that's a bit more interesting later on, but the one I actually care about is the Gimple output. So you can see here there's a bunch of functions being generated. We have our TypeBound test being called with A, and A is this, and this is this. There's a little bit of a bug with how we output the name of structs. I'm not quite sure why this is 100% happening, where we have our struct is missing the name here because we are giving it its name. I remember having it working in one patch, but then it breaks other things, so I need to look at that at some point, but that is bar. So A is bar like we thought. So if I look at the test code, for example, again, we're saying A is bar and B is the result of the TypeBound test. So that's what should happen. And so when we look at the TypeBound test function, this is actually a generic function. It should really, we probably should put the whole turbo fish there to say that this was substituted with bar. It's sort of like a style thing, but in theory this should be outputting the correct sort of mangled assembly. Or does Rust, it doesn't necessarily do that, I can't remember. I'll have to look at that again and see what way that works. Well, some sort of mangling going on there. I don't think it's really doing anything with the generics on it, but it looks reasonable enough. I think it's only with certain cases it actually starts to try and put in the substitutions and relies on the hash making things unique. but anyway, that's a side issue. There's a couple of different representations here. So inside the Gimple, when you make a Gimple tree for a function, you specify the name of it and the assembly name of it. And if you don't give an assembly name of it, it'll default to what the name you give here. So you can give a name like a nice, well-defined name. So really this should say TypeBound test : bar, and that would be a lot more helpful. So you can see here we are calling bar default, bar get. They also should really have a bit better naming here, but we'll fix that at some point. I've been so focused on the pipeline splits up into a few different phases. You know, you have the Lexer parser, then it should go into expansion. We don't have a macro expander yet, but there's the name resolver, then there's HIR lowering, then there's type resolving, and then we finally do Gimple generation. Well, I don't really like calling it Gimple because it's generic. So generic's actually the IR that gets lowered to Gimple. And so Gimple is the same data structures as generic, but GCC will do some more magic for you to fill that out for you. So I'm trying to get GCC to do as much of the heavy lifting as possible, but that still means there's so much work in doing the typing and figuring what the methods are being called. You know, so you do hear this notion of Rust as zero cost abstractions. You know, so that means no virtual tables were possible except for whenever you explicitly say you needed a virtual table. So that means you spend a lot of time doing, like I was saying, figuring what method should be called in which instance. So that's something to remember. Anyway, I've went off in one there already. Then they're probably like 20 minutes in or something. Yes, so that works as fine. But if we then were to, so let's see, test.rs. I think I already have Windows open. Yeah. Let's remove the info. So this will fail. So it's failing to resolve the path. So it should have found a path. Really, this is another bug. In this case, we should be returning error mark node, but this is another issue that we are trying to track. So another thing in errors. In error handling and compilers, you kind of want to let the compiler find as many errors as you can in one go, but actually handle that. So what does that mean? So if you look here, one of the other bugs, I'm going to show you all the bugs in the code today. What am I doing? There's no bugs at all. So we have a lot of this scattered around the code base. If you saw an error, just quit. That's not really ideal, especially coming to making a compiler people actually want to use. There's a certain amount of that where you need, but anyway, so what does that mean? Say for instance we found issues in trying to resolve names. That means you might have one tiny name error like towards the end of your or one tiny name error at the start of your program, but then you actually fail to find a whole bunch of other errors at the bottom of your program, maybe in type resolution or something like that. So it's actually much more useful to let there be errors in there, but then continue on. But then it's a bit tricky because if you got errors, you might have a lot of cases which are just going to cause crashes and so on. But so when you're creating these, some people call them graphs, some people call them IRs, some people call them DAGs. Everyone's got their own name for all these sorts of things. But you can, inside your graph, a node in your tree, if you've got an error there, you can give it an error mark node, is what GCC refers to them as. And so you can actually just let the whole pipeline go through your code to find as many errors as possible to be as useful as you possibly can, which is important to make a useful compiler, as I said. The only caveat to that, and Rusty also does this, is we have this scan dead code pass, and it should also be wrapped inside. It should be wrapped inside a saw errors, because if you've got errors and you're trying to then give you lints on that, you're going to intermingle a lot of warnings in with your errors, and it's going to confuse things because are your errors related to the warnings or not? It's hard to tell. The warnings might be valid, they might not be valid. They might only be valid because it hasn't been able to fully analyze all of the nodes in your whole program. But yeah, I think I've already went off script. I know that I have a script, but anyway, what else do I have? Right, back to code. Out of interest, this is how I actually invoke the compiler properly. So GC is kind of split up into two programs. So if you have let's put another window. Do I have a, yeah, okay, there's a Hello World program been testing with different species. You actually compile to a GC, you do something like this. You know, and you're like, oh, I test Hello World, oh, that's class, that's really, really cool. But if you run this with -v, you'll see a whole bunch of stuff. And so one of the first things you're going to see here is actually, scroll up a bit, how your GC was built, you know, all the different options that were involved in building it, all the different options you've now passed to compile your program. Then it's actually going to invoke, so this is the compiler driver. You can see here, it's actually invoking CC1. So what does that mean? That is actually invoking what we call the compiler proper. So that's what I'm doing over here. I'm actually running the compiler proper, which we call Rust1. It seems to be a bit of a convention to add 1 at the end of these things. I don't really have an opinion, but Rust1 seems like a sensible thing to call. I could do RS1, but anyway, it's called Rust1 for now. And so then we're also passing in a bunch of the arguments that the compiler driver automatically propagates, where as you can see here, it's, you know, adding in a bunch of like architecture options, different security options, and things like that. You can also see the bits and pieces about the include paths, which is actually really useful if you're writing code and hit libraries. You know, you can double check if you've got all of your -i arguments correct, you know, for your include paths and that sort of thing. Another thing that I think some people who may not be familiar with compiler internals is, I always like to show people I've done tree Gimple, and you can run that for any of your programs, even if you're not, even if you're, you know, doing -c. You know, just creating object files doesn't have to be an executable, it can just be for that compilation unit, you know. So we have a really basic C program, and every time you want to input the Gimple, it's always the name of the source code plus this little suffix. And so this should be fairly simple. And so you've got two ways to debug your C code. If you've got issues, sometimes I quite like looking at the Gimple, but sometimes it's also more useful to do, like, was it -e to just invoke the preprocessor and see what's wrong with your headers. But some people might find it interesting. You can see here, you've got a main function, as you expect. You've got a block of code, you've got a string that's null terminated, and you're calling puts on it. And you've set your return value and you're returning. So that's just one of those nice basic programs, but sometimes you can really drill down and see what's going on. I always find it interesting seeing what's going on with variable length arrays and stuff like that. There's a lot of stuff that looks almost like C++ in there, but anyway. Back to the issue. So I want this program to error like this. I want to say when we're actually substituting this type, that this is not implemented for bar and error. So there's a few places this goes on. So we have, this is the first place you see me looking at. As I said, this function call doesn't have a turbofish, you know, so that means we are actually inferring that. So you can see here, type parameter t is being substituted with inference variable, but the required bounds are this, and so the inference variable should be permissive, so this should be satisfied. It should, but the only caveat there is that the inference variable will need to inherit these type bounds to make sure that this is all satisfied correctly. If it's any other type, it would really have to check its bounds. So we kind of need some kind of bounds checking code. And so every type is represented by this base type class, and then we override that, you know, and we'll extend it for whatever we need. So every base type implements this public type bound mapping. So this is any specified bounds. This should probably be a set at some point, but I haven't done that yet. It would be really nice just to have like a custom set class to union your type, when union your bounds correctly, so you're not worrying about, well, if I got duplicate bounds here and I'm going to have to check them multiple times and things like that. It's not super important right now, but it'll probably turn into a bug down the line, and we'll have to then turn that into a set, you know. It's something that I don't appreciate enough, is good data structures. So if you use the right data structure like a set, you're implicitly then getting uniqueness, and so simple things like that seem so innocuous that you wouldn't even pay attention to, do have really subtle benefits down the line. But yeah, you probably already know all of this better than I do anyway. So I think there's a couple of cases going on here. If we were actually substituting with an inference variable, it should then just be like, yes, we're good. Let's just inherit all of those substitutions. If it's not, then we need to then check the bounds of the type. I'm not quite sure what happens if you're putting in never type. I'm not going to worry about that off the top of my head. We'll deal with that and check if there's any weird cases with substituting never type, and if there's any bounds on the variable. See, I don't think you can satisfy any bounds. I think it'll just turn into this, just like another bounds check, and it'll error. Okay. What way are we going to do this? I think we need to have another method here. Bounds compatible. But it should take another. And I'll move it down here, and then we can get access to. I kind of need to write more, more documentation strings. This class is pretty complicated. So we're saying inherit bounds. Okay, that makes sense. So I think this cool piece of code becomes there's another piece of code though elsewhere that needs to be in a really generic place, but the first bit actually needs to be on substitution. So what if we look at another test case to be sure first? Where's Chrome? Let's playground. Let's copy this in. Where am I? Right, let's make it really simple. Let's leave it not implemented. Right. Right, not satisfied, and let's not rely on inference variables. Let's do it like this. So we're actually explicitly at substitution time. Let's get rid of that. So this should still error because it has to at substitution and at argument checking. Yes, okay, it's the same error, makes sense. Let's make this really explicit for now and handle it like this. We might change it later on to be really generic, but it's hard to get to that point until you've ironed out the most basic cases, put in your regression tests and checked everything, you haven't broken anything else. So if I do this and do bounds compatible wrong bit. Looks like my whole language server is dying. Okay, is that working? Okay. It's okay now. Inherit bounds of another type, so right. I think that's the first thing we should get working is this test case. Okay, let's not rely on our the argument checking yet, because that's a little bit of an change which will make this all more and more generic, and we'll do that in another PR. I like to try and get my PRs as small as possible. I was working on such a long time to get these TypeBounds working, and I had a branch that I've been working on for months. It was like 2 months, and I'm still not done, I guess, but it was very painful just staying in a branch, and so you turn out you end up with some commits which are horrendous, like this one, but it kind of all had to go in one go. Unfortunately, I was able to like pull out smaller commits beforehand. There was like 6 or so commits I pulled out that were still nice isolated changes, because I like to make sure every patch is buildable and testable. So yeah, sometimes it's hard to help situations like that. I really, really don't like it. And it's really difficult to find that balance, and I think my fatigue was definitely getting there. But my commit message wasn't as good as it should have been. I like to have really nice commit messages. I think they really help a lot down the line. Like look at that. That's a fantastic commit message. Mark's great for that. I like to always I'm always of the same format. I like subject, description. It's always nice. And one of the things I really, really like doing is linking to issues like that, like this fixes this. I think there's one of the limitations. I don't know if it's a limitation or it's not a limitation, it's just the way people work, I guess. But in GitHub, if you mark an issue and you link it in the pull request, it automatically will close it. I really am not a fan of that. I think there should be an option to switch, because I think there's a difference between fixes and addresses. And so you might be working on an issue that's really, really big. So for instance, another couple of contributors I should say, there's Google Summer Code student Mark Arthur Cohen, and there's another contributor, Mark Pulis, and they've both been working together on multiple file parsing support, and that the and module support has to go along with that to actually make it work. But there's so much involved in that change, and maybe when it comes around to that kind of being done, we'll do the code review as well together. But there's so much involved. There's no way it can be done in one commit. There's no way. It'll take a bunch of commits to actually get that working, but it's still one issue. And so I think to minimize people living out of tree for such a long time, which I don't think is healthy and good for code, I think it's nice to get it merged, the building blocks merged sooner than later. That gets you to that point. And so you could say this commit addresses this issue, and so they should be linked and they should appear, and so you should have a list of all the linked PRs. I would say an issue should have maybe even 10 linked PRs. Makes a lot of sense to me. That seemed reasonable nearly, even if they were ordered, but maybe it doesn't. I think everyone has their own idea about that. Because one of the benefits, I guess, because this compiler is still in early days, the only real rules we really have are to say no regressions, because if we start letting us introduce regressions, what we're really doing is making things more difficult to fix down the line. Some of this stuff and behavior and the test cases we've written are there for a reason, to catch really awkward cases. There's a bunch of that in there, and if we lose sight of that, all of a sudden I think it's more difficult for contributors to get involved. If you've got a stable master that always builds, and that the rule is that you can't cause regressions, then it's easier for people like, well, I've made a change, it doesn't cause any regressions, okay, it's a lot safer to merge at that point. If you're at the point whereby we are actually released and dealing with real bugs people are raising, then you need to be a little bit more careful about what goes in. We can't have, I think it's at that point you have to be a lot more risk adverse at the moment. As long as you're not introducing regressions and you pass their automations, 99% chance it's going to be merged. There's a lot of low-hanging fruit in the compiler to be done. There's a lot of stuff that could be cleaned up. There's a lot of abstraction that we should really be adding, but it just takes time. Like for instance, the whole casting and coercion and unifying of types, it's all so similar but all subtly different in some ways. I'd rather live with some duplication of code for now, until we are sure we have got all of the regression tests we need in place, before we abstract it into one nice clean method that handles all of the cases. It's hard to do everything right the first time. Whether you like the saying, was it Elon Musk was saying, is it not even Einstein was right the first time. No one's right the first time. No one writes perfect code the first time. So I'd rather deal with the duplication and deal with it down the line. So I think it's a good trade-off to actually keep progress forward. And they've already went off on one anyway. Okay, so let's fill out these two functions and see how that goes. So we're inheriting the bounds of the other type. So we could probably add some helpers here. We do actually have a union function that we might be able to reuse. Do I want to call that now? That would be quite nice. Where is that? No, it's not here, is it? No, not that one, not this one. That's the one thing in a feature I can't live without is go to declaration. I just can't cope without that anymore. And LSP mode seems to work bloody well these days. You can see here, oh, this should really be const, but there's probably some tweaks we need to do to make sure everything else is const before we can do that. I think actually const is really important in C++ because if you don't know what's const, you don't know what you can change or can't change. Yeah, let's grep for it. Right. This is really not nice. We should just make a C++ set and actually implement the comparison operator, because really these should be really the way to differentiate these trait references is by their def ID, so then we know they're unique trait items. Let's not necessarily worry about that right now then. Let's just add them. We could do it like this. Protected void add bound. Probably loads of copying going on here, but it's okay. Why is it not like that? No matching member call to function call push back. Oh wait, I'm doing the wrong way. Predicate. Oh, can't believe how nervous I am. Right, add bind. Okay, so there's inherit all the bounds. And let's start checking all the bounds. So what way we need to do this? What way around is it? What way do we call this? Through a lot of different buffers today. Okay. in this function. Okay, so we're saying, is this parameter bounds compatible with this type? So we need to, we're saying, are all of the bounds in this contained within other? Okay, so what if we do for auto bound in get specified bounds Is that spelled right? Because you want to like iterate over all of them and get errors for all of them, or do we? Do we want separate errors for each? Or do we want to create one error? Yeah, that's still okay. Now we need another function. Satisfies bound the wrong bit. That could be public. Why is it erroring? Hope people are finding this sort of interesting at the very least. So we're discarding const qualifiers somewhere. Other. Can I do that? Does that fix it? Yeah, I think it does. Yeah, we don't need that to be anything other than constant. Then we can do unsatisfied bounds. Bound. Right, okay. If not satisfied, actually let's get rid of that and make it even simpler. Make it like data driven. Okay. Let's actually make an error. Rust error at which location are let's give this a location here where we're actually going to check. Going to do separate errors, isn't it? What if we do it that way instead of trying to do like a fancy rich location error? Bounds can also be optional, but that's something we can deal with later. We'll keep that list in case we want to do some more errors. No, we should keep it all in one. No, we should keep it all in one. What am I doing? Let's go back to what I had. Need to improve that error message. Satisfy bound. So actually find it by def ID and just match it up that way for now. Put them pretty good. let's actually do this in here. So it's the first type. Fine. Oh, I feel like we've been talking for a while. Let's see if this fixes it. Come on. Oh, nice. Okay. Let's see, does this work? That's one thing that's a bit crap in, well, it's not crap because I like GDB, but I always run with make, but you can't do like make minus j something. It thinks it's like an argument to GDB, so that's a bit annoying. But if you keep things in GDB and you have an unexpected crash, well, at least you've got your backtrace there, and then you're not like spending time, alright, I have to figure out how to run GDB again. And then you can actually go and look inside where you are. But that's about the height of what I use GDB for, is getting a backtrace. And from there, I spend more time just putting in debug, printf. And then you can stash it so you can get rid of your debug, printf a little bit easier sometimes. And then drop the stash. Okay. Bounds not satisfied for blah blah blah. Right, which bounds? That's the starting point. Do we have any regressions with that? Let's see. This is run the whole test suite. If we don't have regressions, I'd be tempted just to clean up that error message and let that be the first the first implementation of getting this type-bound error. And I hope you find this interesting at the very least. And really appreciate it if you tuned in and actually check this out. While this runs, you may as well check out our project over on GitHub. We also have a Zulip server, which is free to join. I actually keep a full reporting repository, which actually shows you all the different reports that throughout the whole time I've been funded on this project. It's kind of funny because I was initially doing it in a bad format, and so then I had to reorganize the whole thing so that I kept things in order by date correctly. So you want to do the year, month, day sort of style. There's a report that's meant to go up today, which I'll do later, which is the community call. So we have a community call every month. Do I have that here? Well, it should be here. And so we actually keep meeting notes of this. There's some extra information which needs to be added here. So then that will also be added to the reporting repository. But feel free to check out the repository. There's issues, there's pull requests, there's automation to check your pull requests. There's a couple of different projects. So there's the compiler, there's reporting, there's cargo, GCC Rust, and there's a sort of website main page, but it drastically needs a bit of an update. But we'll get around to it. There's a lot of work ahead of us, but I think actually having a lot of work to build something is pretty exciting. I find that inspiring when you see other people take on challenges which are very difficult. And here we go. Yep, we've already got a bug, so we've caused a regression somewhere. So that's the whole point, whereby we want to see, well, what have we broke now? Wow, traits 8. Torture, is it? Torture. So, binds unsatisfied for bar. Okay, I think I know what the problem is here. We're missing one last piece, which we'll need to bring it into the CPP file to get access to everything we need. So one of the things in Rust is you have specified bounds, but you also have, I don't know what the right word would be. It's not auto traits. It's like implied bounds or something like that. It's probably called. So this is only caring about the specified bounds. Satisfied bound is there. Okay, yeah. Maybe that's already in there. Okay. So the interesting piece here is we're saying, as we said at the start, is that T must satisfy foo. So in this case, we're substituting with bar. But bar is not explicitly does not explicitly have the trait bound applied to it here. Like, you know, the compiler's like, oh, we've got bar, but it does satisfy the trait foo because there is an input block here. So what we can do is we need a way of saying, need the trait resolver to be able to tell us, is this trait implemented for this type. So we've got a function now that we can do this, satisfies bound, so that's us iterating over the specified bound in the type. We do a check for a trait impulse on this type. So we've got, there's some code in here that might help us. Maybe it's a better way to look at it be here. Impl item. Yeah, type check impl block with trait. So we have this and it has this trait reference. Trait reference. Okay. We need a way of checking that. That's a missing function now. And we need something here. Type check item, impl block. So when we actually do type checking on impl block, we actually get the trait resolver to find that trait for us. But that's it. We need some way of finding all the traits available on a type. It might be possible with Path Pro. Do we have something here we can reuse? So probe bounds, type bound probe. Oh, do I already have that? Okay, maybe I already have this. What if I do this? Probe include Rust HER type bounds H. Probe. Needs the receiver. We don't have it here in this case. Do we want to move this function? Am I trying too hard to keep this all in place? Yeah, I think I need to move that. I need to move that out. That needs to go here. Yes, type. Okay. So then we get this back. So this is us finding here that bar actually implements bar, implements foo for bar, so that means we implement this trait. So we're looking to we implement any other traits. So this is us here. For it's going to be the same function again. Probed. That's a bit of a nuisance. That should automatically turn into this. If I do this, this will probably fix it. Figuring out const isn't perfect in C++. Oh wait, I've already got the... What am I doing? Okay, let's bring it... I don't leave that back as auto. Yeah, it doesn't like it when you're behind the reference wrapper. Okay, let's see if this fixes it. So it should be able to find that, oh no, it is actually implemented, sorry. It's difficult because you're kind of forced to always probe because the whole context of this is kind of building up as you go. You don't know, if you try to do it up front, you can't really do it like that. This is why I think whenever you start doing traits, you realize the Rust C compiler turned into a query-based system entirely. At the minute, ours is about mishmash, where some parts are kind of query based, but it's not fully there like that. But you're kind of forced to start thinking in a query based way very quickly when you start looking at traits. Maybe discuss that in a future video because it's not very well documented, it's not very well understood. That's maybe a pretty unfair thing to say, but I think there's a lot to learn from the Rust C compiler. It is kind of the state of the art in my eyes of how you should write a compiler. There's so much good stuff in there. It's pretty impressive. There's a lot of work in it. Okay, so that fixes it. Let's do another regression run on a test case to prove that our thing is breaking. The error message needs a little bit more context and information, but I don't necessarily care about that for now. I want to double check what the Rust C compiler does when there's multiple trait bounds, not matched. And so, do you get multiple error messages or do you get one error message stating the bounds that are missing? That would be interesting to know. I think there's a way to make the test suite parallel. I think it does do respect -j, and this looks good. Brilliant, right. Let's go back to our original test case. Breaking again. These are GNU annotations. So let's remove the info block, that's what we want to remove. Leave the background. Oh, it's not satisfied for bar. Right, let's remove that. We don't need that. We also need to get rid of those. This message. Come on, compile, please compile. You know how to compile. Thinking about it. I mean, my computer's pretty good. I mean, I've got 8 cores. And I'm not using any of them when I'm doing it, when I'm compiling like this. But it's GDB takes a while to start, and so I'm just sort of getting used to it. What I could do is actually just do -j, here, and then just switch back, and GDB will notice that the binary changed anyway. So that's probably what I should do. But sometimes it's just nice being in the same window, because if you start switching windows and making in one of them, making in another one, you forget how have you actually built your latest code, and then you realize you're debugging something, and you realize you actually haven't compiled the right bloody build folder. I keep multiple builds of GCC around because I like to test the latest Git version, just to see. So I do install it into so GCC master, Benutils master, GCC Rust there as well. So I like to have that there to look at. Okay, so how do we actually write a test case for this? It's quite easy. GNU lets you be quite flexible in this. As I said, the error message isn't great right now, but that's not the goal here. There's going to be more places where we need to add this code. So, let's look at our test suite is broken into 3 different places. There's compile, debug, execute. So execute is obviously, we're going to execute these tests. We're going to make sure these are compiled and actually executed, and we check that the error codes are correct and warnings and all that, and they're ran with all the torture options, of the permutations of debug on, off, and optimizations on, off, and the different levels of optimizations. Because what you'll find is when you're writing a compiler, Very quickly you might find something works and no optimizations, and then all of a sudden doesn't work with optimizations on, or vice versa, and so that's not good. That's not what you want to happen, so you have to make sure that's correct. So, but we care about compile tests, so the compile tests are sort of split here. There's X fail, so these are ones that explicitly should fail and we do not support yet. Torture tests similarly, but we're just sort of checking that they compile and output certain things, like be it in their Gimple or assembly or whatever. And these are generally, this is a dumping ground for all the test cases which should fail and put out an error. So like, you know, like a simple one, redef error 1. This structure was defined multiple times, so that should error, you know. So let's just copy. This is the annotation we want to use to enforce this check. So the check is line 7. Yeah, so it's here. But is not satisfied. The location is maybe not 100% correct here actually. The location should be here. Yeah, let's change that location. Bounds to generic. That's type parameter. Parameter type. Bounds compatible with this type. What we could do is see if this works. This might just magically work. Do we have mappings here? Fill. No. I think we need to pass the location down through substitution argument mappings. Okay, yeah, let's do that. That's what we want. Location, locus. Because what you can see here, we've got the location of that. But what we really want is the location of that, not that. And so we really want the location of that with like a reference to that or something, you know, like a rich location. It doesn't matter. Locus. We could change that later. We could make that quite nice. Just get locus. Okay, that's fine then. I hope this is interesting, everyone. So locations are, you know, source code locations. GC has a thing called a line map, and so you can create locations that reference column length. What's the right word? Column is that way. You know, which column are you in? Which row? I couldn't think of Excel there. So which row are you in? What file are you in? Right. So we need to fill these in here. 587. I wonder, am I the only YouTuber using Emacs? Maybe there's someone else, but there doesn't seem to be many people that do that. So in the compiler, arguments are sort of wrapped up into objects because you need to be able to handle these things recursively, and you can't sort of manage the IR for that purpose alone recursively very well. It becomes very unwieldy. You need to be able to make that in an abstract way that makes sense. You know, because there's a difference between and some of the types, you know, some types are covariant, like an array. So an array has a type, which could be an inference variable, which might get substituted later on. So that's what's seen as a covariant type. But then you have functions and algebraic types which can have substitutions on them, can define type parameters upon them, but things like arrays don't, but they are covariant. So there's a lot of different sort of niggly things to handle when you're dealing with what do we call it? Generics. Okay, where am I? It's in that one. We need 867. 867. So these are the only two ones. Yeah, Lucas. Right, that should fix it. We'll have an error in the correct place. Yeah, there we go. So we've got the error in the right place this time. Let's finish this and get it committed. Well, up as a PR. Let's do this. This is a little bit better, this annotation. So what we're saying here is on line previous. Actually, let's do this one. I don't like that one with lots of brackets. Right. What's the error message? Let's just give a bit of it. I can't never think what's the best way to name these things. So when it comes to doing compiler work, things layer up on top of each other. It's kind of like, I imagine, like a house or a circle coming around like that and being filled in. So if you want to actually compile Rust and usable programs, you're building all your core stuff and they sort of eventually wrap around till you get to a point. Then the circle's not filled in, kind of like a house, House might look like a house, but actually has no windows or no heating or cooling or plumbing or electricity, so it's not usable, but it looks like a house, so it's sort of there, so compilers are kind of like that. Yes, you could, get out of the rain by getting in the house because there's a roof, but, there's no electricity, you can't make a cup of coffee, so it takes so much work till you get to a point where you are able to compile enough stuff that it starts becoming useful. And so that was one of the things that got printf working recently, but it took a long time to get to that point. Let's make a commit message. Checks for TypeBounds on argument substitutions. Did I spell that right? I always get it wrong. Addresses, some bug number which we should have. Type parameter contain specified bounds. When we substitute them, we need to ensure that the argument satisfies those bounds. Otherwise, is it UB, undefined behavior? I don't know. It's broken. Otherwise, it fails the contract. It only checks for this specific case as a nice isolated how to demonstrate the bounds, specified bounds are checked, but we must also probe for what bounds are available for the type. So what I should do this address. Projects. Trait constraints 1440. So to me, there's a difference between type bounds, trait constraints, and where constraints. So trait constraints to me are saying when you're doing an impl block, you ensure that the impl block implements all of the trait items as you expect, all mandatory trait items. But we're also saying in that same point that the traits, trait bound constraints are checked as well. So there's quite a lot of things going on there. So yeah. Let's make a new branch. This seems really superfluous, but I've already merged traits dev 17. And I kind of like to track the amount of branches I've had to create that are in relation to this work. So we're all rebased, so push origin, fill traits devs 18. Open. No. Firefox is crashing, so I'm using Chrome today, which I don't know. I don't really have an opinion on. Oh, spelling mistake. Tables enhancement. Bug, I guess, as well. Projects, traits, milestone traits. Edit.com. Let's fix my commit message. Looks a bit broken there. Okay, that's fine. Looking good. That's changed. You can see here, I've added a function for satisfy bound. Invocation. It's an as string, it's kind of helpful. Add bound. That should really add specified bound actually. Bounds compatible. This should really be a little bit of a richer interface, but I'd rather do some other changes first before changing that. Okay. Okay. Thanks everyone for watching. I hope you find this at least interesting. I want to maybe continue doing this in the future, and thank you very much for watching. Bye.